Good morning and welcome to another Crawford Cogitations. Wanted to start today by actually having a conversation about energy and energy transfer and where it came from. I think this is very important for us as we study renewable and non-renewable energies. So the question for today is, what does scavenging for nuts have to do with the last flight you took? In your literacy journal, please make sure that you write down this question. So here we go. Let's get started. Energy is the basic human need that we have. And if you think about it, we started with this idea of somatic energy. And that's the energy that we use to put into the body. And it actually has direct consumption so we can end up doing work. Well, what ended up happening is fire was introduced to early humans, and that allowed us to start looking at extra somatic energies, which means that we could capture energy from somewhere else. It actually started allowing us to be able to cook. In antiquity, we actually saw this coming through, and in the Romans, they used the hypocaust, and this was a raised floor that actually was heated, and this was used in their bathhouses. The Chinese have used elevated beds for a long time in northern China in order to be able to keep people comfortable. And that's what you're seeing in this picture here. In the Korean community, what you had is actually an ondol, and this is where you actually had a fire that was below the beds that were being slept upon, or the rooms that were being used. So if we look into the late Middle Ages, we started seeing the use of windmills to actually pump water and actually to process crops. Then we started seeing blast furnaces used to make cast iron, and then gunpowder, of course, for projectiles. When we get to the pre-modern era, we look at the clepsydras, which is actually a water clock, and then pendulum clocks. These were actually used as they were converting energy to keep time. These were more of a show-off piece, a piece of art, rather than actually real need or use. The early modern period actually saw water wheels, windmills, sailing ships, and steam engines. And then we progressed to the 19th century, where in the 1830s we saw the first water turbines. In the 1880s we saw steam turbines introduced, the internal combustion engine, and electric motors. And then by 1890s we were looking at diesel engines. But this is all about energy transfers. What can we do to end up making our lives easier? We finally get to the 20th century and we look at gas turbines in the 30s, nuclear reactors in the 50s, and those were used actually in the first submarines. And then looking into the wind turbines in the 80s, and that was dealing with the price of oil. And then in 2014, we saw another resurgence of wind turbines, but this time in offshore applications. You have to keep in mind that there are different ways to convert energy. And what we have is water wheels, windmills, water and wind turbines, steam engines, and turbines. And then the internal combustion engine. This also includes the nuclear reactor and then photovoltaic cells. These are all making energy. So they're consuming that, whatever process is trying to be addressed, whether it's a kinetic energy or a chemical energy, they're all being used. But what we tend to use as consumers is the secondary pieces, which would be lights or even machines. Believe it or not, there's 30 little motors that exist in your cars. Just small little motors, servo motors, which are just electrical devices that are used to make our everyday lives easier. Take a moment right now and write a statement or two about the things that you've heard already. Let's change our focus here for a moment to the resources that exist in Ohio. This is from the Energy Information Administration, and it's a map that actually shows the different fossil resources that exist in Ohio. You can see that the coal fields are in the south eastern side of the state. You have oil shale that exists north and south to the east of Columbus, and then you have a sedimentary basin just outside of Columbus. These are actually the coal mines that exist in the area. You can see that that's what we've used many times. These are pipelines that actually move petroleum products throughout the state. Many people don't realize that this is going on, but right under your feet there could be barrels and barrels of oil being passed below you. These are the power plants that exist. Each one of those icons actually represent a different energy source that is being produced in order for us to live the lives that we do. And then you get the high transmission lines, which are talking about the ones that we see right outside our school. These transmission lines drape all over the state, and they connect the power plants to the consumer. What people don't realize is how much energy is actually used in Ohio. So these are different charts that are explaining the rank that we have out of the US. So in total energy production, we're 10th. In coal production, we're 15th in the country. Net electricity generation is at 9. Total carbon emissions is at 6. And then energy consumption is number 23. So if you think about it, Ohio is actually doing a lot when it comes to energy production and consumption. Take a moment and write in your literacy journal a couple thoughts that you've had from the last couple of slides. Let's start looking over to the US as a whole. If you look at what is being consumed right now as we speak, 36% of our consumption is coming from petroleum. Natural gas is increasing. You have coal that is dwindling, nuclear power, which is staying pretty stagnant, and renewable energy, which is slightly increasing. That talks about geothermal, solar, wind, biomass, waste, biofuels, wood, and hydroelectric. If you look at the consumption since 1950 to 2018, you can start seeing the different changes. Natural gas is actually getting bigger. Coal is getting smaller. Petroleum is staying relatively constant in the last 20 years. Nuclear power is staying relatively constant. And then the renewables are slight gains. The economy is broken up into different sectors, and this is showing the energy used by sector. The blue line actually talks about residential sector, and that's what you would be living in your house. The commercial sector would be anything that would be a building of business. So that would be any restaurant, any grocery store. If you look at the green line, that's the industrial sector, which is talking about manufacturing. So, and then the last one is the yellow, the transportation sector. You can see how the yellow one continues to go up as we rely on being more and more mobile in our society. What you can see, this is an energy diagram that actually helps you understand where the flow goes to. So where does petroleum go to? And on the left-hand side, it's the source. And then on the right-hand side, it's the sector that's being used. You can see that transportation is using the most in all of our consumption. Let's take a look now at the world and energy per capita. The darker the red, the more energy that's being used per 1,000 persons. Energy consumption is still going up in crude oil. If you look at nuclear energy, there's quite a discrepancy. France has put a lot of investment into nuclear power, but you can see how Germany and Japan are dropping off. The United States is staying about the same. And that comes from no new nuclear facilities being built since the 80s. This is a diagram that actually shows who's using more energy now. You can see the US, or you can see North America is kind of stabilizing a little bit, but you can see the Asian Pacific is actually increasing dramatically over the last 30 years. And this is showing by source. Oil continues to go up, coal is meandering, natural gas is increasing, but you can see the ones on the bottom, which would be considered the better ones, are only showing slight increases. This is something to keep in mind as as many of you may think. People think that the U.S. does not have a lot of fossil fuel production, but if you look at this diagram represents the rankings. The United States produces more fossil fuels than any other country in the world. And you can take that and look at the total oil production. Oil production in the U.S. is greater than Saudi Arabia, it's greater than Russia, it's greater than Canada, China, Iraq, Iran, the UAE, Brazil, and Kuwait. So the U.S. is still producing more oil than anybody else. When it comes to natural gas, the United States, again, is a leader in the world. Coal production, we are actually ranked third, where China is putting a huge amount of investments into the coal industry, and India is finding more and more resources there. Take a moment and write a couple of statements in your literacy journal. Let's briefly talk about the idea of renewable energy investments. The United States is down at the bottom. If you look at that, their investment in renewable energy is actually increasing again after it saw a drop in 2011. But you can see China is doing a huge amount of investment into it. And this happens to do with a lot of their hydroelectric power that would be going on. It's important that we keep in mind, as the richer countries get richer, the cost for what they do gets less expensive. So this is showing you that the low-income countries are actually having to use more energy to produce the goods that they come out. If you look at the high income, they actually have the lowest values when it comes to the production. So what does this have to do with everything? If you think about jet engines, and talking about the production of or the progression of our industries. In 1976, we could only travel 90 minutes on a two-engine airplane. 85, you saw the number go up. In 88, you saw it go up to 180. 2009, it's 240. And then when you get to 2010, the introduction of the Boeing 777 gave us 330 minutes in the air. And then in 2014, we are able to do 370 minutes in the air. So essentially, you could lose you can use an engine on a flight going to Europe and still make it there. The intent with this slide deck was to get you thinking about where we have come from and just kind of give you a background information on how things have gone to get us to this point. At this point in time, if there are any questions, go ahead and jot those down in your literacy journal. So how do we react as a society knowing that these increases are going up? So I hope that this found So I hope this was an informative piece to help you understand how we've gotten from the energy consumption as the hunter-gatherers to actually the flight of airplanes, and how quickly we can get from place to place